Okay, so I'm going to hide both these. I'm going to pop into this. There. So we just discussed that if we drew a picture of this, we're literally setting the mechanical energy initial equal to mechanical energy final. That's where this problem begins. Cole just told us that the mechanical energy initial would be mgh in some initial aspect. I believe that. That's going to be the energy of the ball at the top of this. Okay? And it's dropped with no air resistance and probably going to have no kinetic energy. So it's just going to be isolated like this. Now, I guess my question would be, I don't know. Cushy, can you actually read what I'm writing on the board, or is it too small, or whatever?
I can't see.
She said can't. Did you say you can't see, dear, or can?
Can't.
Can't see. Okay, got it. Let me see what I've done. There, is that better?
Yep.
You're going to have to pin on my view. You're going to have to go off of my presentation screen, and you got to go to the kid in the classroom. That's me. Does that make sense? I hope. You've got to pin on that picture.
Yeah, it's fine now.
All right. Is it backwards when you're looking at it? Because it's backwards in my screen.
No, it's not backwards.
That's crazy. I look at it and it looks backwards. Okay, sweet. Thanks for letting me know. Yeah, your old job in hybrid when you're at home or RLA is you just have to yell at me and say, man, I don't even know what you're doing, Maddie. I can't see that. Because, my screen gives it to me backwards and it looked like it was okay, but it's not. Okay, so I hope everybody sees what I'm up to right now. And so then I got to think about, it says it's dropped a distance h with no air resistance. It doesn't say it hits the floor. It just says the power exerted on the ball by gravity in this process. Okay, so tell me something else that I might need to put up here. Ben, what should show up in the mechanical energy final portion? What do you think?
The equation like kinetic energy.
Oh, for sure. For sure. Is that the only type of energy over there? What do you think? Should we add some other energy?
Yeah.
What?
Potential energy.
Yeah. Good job. There we go. So what we're really looking at here is this idea that the change in energies are going to give us 1/2 mv squared. Okay? So let's rearrange this equation a little bit so that we have okay? And let's realize full well that once we've established this, we can also say that we've headed with this, and maybe I'm writing off of the board, I'm getting close to writing off of the screen that everybody's looking at. So we've established that a change in height is going to give us the work done by gravity. And it's also going to equal 1/2 mv squared as well. So if it's asking us, what is the work done by gravity? That's fine. But look, that doesn't give us any of the solutions. Like mg with like a standard h, that is option C on the board, but that is not power. Okay? When we're talking about power, we have two ways we can go with this. We can go with work done divided by time, which this didn't give us, or we can do force times velocity. So maybe what we can do is we can look at work done by gravity as being equal to 1/2 mv squared, but now we are going to substitute in for v using, yes.
We can't see the bottom part.
Got it. Can you see it now?
Yes.
Okay. All right, so what I'm going to do is this. I'm sure that's making you sick, whatever I'm doing there. There. That should help. Is that good?
Yeah.
Sweet. So look, I got stuck doing my equation. Now I've got to unstuck myself. If I said mechanical energy equals mechanical energy final, and that equals work, then I'm using substitution, and now I am establishing a way that I can deal with this v squared, and we know that something falling, you have this final velocity squared equals an initial velocity squared plus 2gy. Okay, well then, look what we can do. Look what we can do. And I think we just figured out how we can solve this out. Okay? Look, two different ways to prove what we're trying to go for. So if work equals mgy, now we've got to do a little substitution in for power. So from this equation, let's get a VF. I hope this makes sense. think we're getting somewhere. Oh, I think we just found our answer. Okay, let me take a picture. Ashma, I'm going to take a picture of that for you. What do you think, people? That's a long way to go, but I thought that was kind of a little creative way to finish that thing up. So here's what I would like to do right now with everybody is I want to take a look a little bit at the agenda for this week. That way we can kind of see what we're in on and what we're up to and all that good stuff. Because I know this is going to be a little bit of a stranger week for everybody, for sure. So let's just see what this week has in store for us. All right. Look, we didn't have school yesterday. And yesterday, my dates are off just a little bit. Today's the 19th. So today, what I'd like to do is I'd like to just study a little bit about what's going to be on your quiz tomorrow. Tomorrow we're going to take a quiz on work energy. We're all going to take it. Whether you're in here, I'm going to have my A-Day crowd in here. My B-Day people, you'll just be taking it online. No big deal. And then tomorrow we'll start our work and energy test review sheet. I can give that sheet as paper, or I can give that sheet as a Cami doc. It's whatever you guys want to do. And then if we look at Thursday, we're going to watch a little bit of a video. We're going to talk about this work, energy, and power test. And then we will prepare for the test tomorrow. So, and then you're going to have time to work on a little bit of the review sheet. I'm contemplating on whether to give the work energy test as a take-home or as a Schoology. I'm not sure. It's going to be a small test, though, by the way. But we've got a wrap-up test. We got to wrap up all things we're doing on work, energy, and power so that we can move on into the next parts of our curriculum. So just wanted to give you a little heads up on due dates, too. It says that we've got a stopping distance simulation, which I don't believe many of you have had a chance to start. That simulation is going to be due 1:22 at midnight. We're going to be doing that today. The Lab 7 work and energy, I see that a few of you have started turning it in. Nice job. I want that thing due Friday by midnight. So our test on Friday, we'll kind of figure out what's the best way to deal with it, whether we're going to do a small in-class test or whether we're going to be doing, a take-home test. I haven't quite decided yet. But, let's talk a little bit right now about what I would like you to be ready to do in quiz format for tomorrow. For tomorrow, oops, I'm just kidding. I'm on the wrong screen. Here. Tomorrow, what I think we should be able to do is we should be able to do any calculations for work power and then work energy theorem. All right? We should be able to do work done by a spring on a block. I also think we should be able to do simple work energy problems now. Like the things we did with bar graphs, you will. have a bar graph, which is the graphical interpretation of work energy theorem using bar graphs. You should be familiar with your chapter 7 homework problems. How about lab number 7? The ideas behind work energy theorem. And then our Wiley's test generator as well on chapter 6. If you feel like you want a little extra, I'm going to take one question off that Wiley's test generator, and I'm going to put it on your quiz. Word for word, answer for answer. All right? So that's on your agenda so that you can always go back and see it. But I think what I'd like for us to do now, I think I would like us to open up the simulation. So let's go into the week 19 folder and let's open up that simulation because I know we didn't get a chance to do this. I'm 100% sure. I think you actually may have gotten the simulation done. Is that correct? Because I know you were a little bit ahead of the curve. Priyesh, what do you think? Did you get that simulation done?
Yeah, I think I did.
Okay, man, that's outstanding because that is what we're going to be up to in class today. So you can go into the week 20 folder and you can start working on that quiz review topic. Okay? So for my money, ladies and gentlemen, what we're going to do is we're going to open up this week 19 folder. In the week 19 folder, you're going to see a stop distance simulation. Oh, Ashima, you got this done, so you're good to go. I'm going to cut you loose. I'm going to stop my Screencastify, so you're up with everything we're going to do today.